Okay, this is 1.6, Applying Quadratic Relations. Question 1 I've completed a little bit ahead of time. I'll just read the question and go over what I've done, and then I'll skip to questions C and D of question number 1. So an interior designer is deciding what hourly rate to charge for her services. She knows that if she charges $60 an hour, she will get 30 hours of work per week. She also knows that every $5 increase in her hourly rate, she will actually lose 4 hours of work per week. So you were given a table of values to complete. You know from the question that if she charges $60 an hour, she will get about 30 hours of weekend work. To find out how much she makes in a week, that's your weekly revenue. So if you charge $60 an hour and you work for 30 hours, 60 times 30 will give you how much you work in the week. So I've completed the table ahead of time. It also told us in the question that if she increases her hourly rate by $5, she will lose hours of work. So right here I've subtracted 4 hours because she increased her hourly rate to 65. So from here to calculate your weekly revenue, you are now calculating 65 times the 26 to give you 1690. So I went down hours by 4 going this way and went up going the other way. So that's how you complete your table of values. I will also post these answers online as well. From here you can plot your graph. So our graph, we want to graph the relation between hourly rate and weekly revenue. So our hourly rate will be on the bottom, that will be our X value here, and our Y will be our weekly revenue. So our Y value is our weekly revenue that we calculated. When you plot these points, so the X and the Y values on your graph, you will get a parabola type shaped graph that looks this way. Okay, so you can tell that it's a quadratic relation because of the shape of the graph. It's an upside down U. If we go on to question C, it says write a relation in the form y equals a times x minus h squared plus k to represent the graph. This, of course, is our vertex form for quadratics. This is what we've been using for this unit. It helps us to graph quadratic relations because we know what our vertex is. Our vertex is the h and the k. If we use our information from our table of values and from our graph, we can see that our vertex occurs here on our graph. This happens when she charges an hourly rate of $50 and she gets, you can also check your table of values, when she charges $50 she gets a weekly revenue of $1,900. So this is important for our question. We know that our vertex occurs at $50 an hour and she gets $1,900. Knowing your vertex is going to help you write this equation. So if we plug this into our equation, our vertex. So our vertex, we've plugged it in. Now, we don't have the complete vertex form because we're missing this a value. We don't know what our a value is. So we have to find a value. Find the a value. Now, to find the a value, the other things that are missing in this equation are the x and the y. Those are any points that we have on this graph. So what we can do to find your a value is make it the only unknown in the equation. So if we can substitute something in for x and y, we can figure out what a is. We have a table of values of lots of x's and y's, so you just have to choose an x and y that you want to use and plug it into the equation. So choose an x, y and plug it in. I'm going to choose my first x and y value, my 45 for x, and my y is 1890. So 45 and 1890. Once I do that, all I have to do is plug those values in. So 1890 goes in for the y. We don't know what our a value is. We're still looking for that. Our x value is 45 that we picked. And then we know our vertex based on our table of values in our graph. So from here, it's just figuring out the a value. So we'll do, when we do what comes first, we have to do our brackets first, our bed mass. So 45 minus 50 is -5. So -5 squared plus 1900. -5 squared is 25. 25a plus 1900. We want to figure out what that a is. We have to move the 1900 over to the other side. If we move it to the other side, it becomes negative. 1890 minus 1900 is -10. Okay, we'll just go up here. And now you're just solving for a. So you want to move your 25 over to the other side. Since it's being multiplied by a here, we're going to divide it to get to the other side. So -10 over 25 equals a. We can simplify this a little bit by dividing both the top and the bottom by 5. So 10 divided by 5 is 2, and 25 divided by 5 is 5. So our a value here is -2 over 5. Now that we know what our a value is and we know our vertex, we can plug those values in. So y is equal to -2 over 5 is our a value, x minus 50 squared plus 1900. And this is our equation in vertex form. So we've got our vertex that we know is 50 and 1900, and then our a value, which we just found by substituting any xy value in our table of values into the equation and solving for a. Okay, so now that we have our equation, we can answer part D. What hourly rate should the interior designer charge to earn the maximum weekly revenue? Well, our maximum weekly revenue is, of course, where our vertex occurs. We know that our vertex, so our vertex is at 50, 1900. So, what hourly rate should the interior designer charge to earn the maximum weekly revenue? Our max revenue is $1,900, and this happens when she charges $50. So max revenue is $1,900 when she charges $50 an hour.